Welcome guys, I'm Dr. Avitech, and in this video we're going to be treating how to find the period in non-sinusoidal functions. Remember to hit the subscribe button, like this video, and share that across to your classmates. Now, earlier on we've looked at what period is. So we've agreed that period is the time it takes for a function to repeat. So we can also say that the period is the time it takes to complete one full turn or one full cycle. So that is what period is. Like what's the time it takes us to complete one full revolution, which is 360 degrees. Now, if you look at the first question, it's actually asking us, if you look at that graph carefully, at what point do you think there's a repetition? One thing I always do is I kind of look at where the graph is starting from. So I kind of notice that it started from 4. Yeah, started at 4. And I'm going to look for that same position somewhere else. And I'm going to say that it's here also, starting from 4 too. So let me say this is A, and let me say this is B, and let me say this is C. Every single point I've written currently, they are all starting points. I kind of like calling it starting points. Now, when I do this, I still have to check if they are ending at the same location too. I still have to check if they are ending at the same location. Now, I've seen that A, B, and C, they were all starting from 4, meaning, you see this y-axis here. If I should draw the y-axis here, so I can say this is y-axis. I can say this is also the y-axis. So you can see that it's like a repetition of what happened previously. Now, I kind of noticed that since I've said this is the starting point, meaning this ended at 8. This started from 0 down to 8. Then I notice again, if I should add 8 again, will I have the same thing? 8 plus 8 will give me 16. Now, if you notice, this 16 is also appearing like what 8 appeared. Remember, from 6 to 8 was a straight line. From 14 to 16 was also a straight line. The distance between 6 and 8 is 2. Distance between 14 and 16 is also 2. So what can I say? I can say that after every 8 seconds, depending on the unit, this time around this was millisecond, so depending on the unit of time, after every 8 seconds, 8 minutes, or 8 whatever, after that very time, the function is always going to go back to where it started from. So this very function here got to 8, and then before you know it went high again, started at 4, and then kept on going the same way the first one went until it got to 6. So in this case, if you notice, when you add 6 to 8, you get 14. So when you add this very same 6 to this 8, you get 14. So it's like, the same thing. It's still the same function, but it's just a continuation. So it's still repeating, it's just a continuation. So I can say that the period here is equal to 8. So T is equal to 8 milliseconds. That's what the period will be. Now, how about this one? Okay, like I said, I always notice where it starts from. So here is the starting point A. And the way it's starting, it's going up down to 3. It's going to 3. It's increasing. So it's going to this direction to 3. I'm going to look for another place in this same graph where that same thing happened. So if you notice, this also repeated itself here from 0, because this line is actually 0. Yeah, this very line. The value of y on this very line is 0. So started from this point and then went up to 3 again. So this is the next point that it happened. And I can tell you that since from here to here is 6. 6 is the period. And it's actually very simple to solve. 6 is the period. So if you notice, whenever you add 6 at any point, you will get the next corresponding point. Let me explain. Period means something is actually repeating itself at a particular time. So currently I've said, okay, it's repeating itself after every 6 milliseconds. Now, if you look at this graph again, we've been able to show that this is 0. It spiked, it went up. So it went up. Then this very 6 now went up again. So the period is 6. But let's take a look at this is 2, right? When it got to 2, it started coming down. When it got to 2, it started coming down. So since we said 6 is the period, if we should add 6 to this, because if you should add multiples of a period to a function, you will get the same function. So you get the same location, the same point you are actually trying to calculate. You will still get that same point. So 6 plus 2 will give us 8. That's the 8 here. And if you notice, when you got to 8 here, it started coming down again, the same way it came down when it was 2. So if you keep on adding multiples of it, you'll be noticing the same type of graph is repeating itself. So the period here is equals 6 milliseconds. Now, how about this one? Okay, that's actually beautiful. It's still fine. So here's what we're going to do. Like I said, this started from 2, right? Yeah, this started from 2. So from 2, it went straight 2 before coming down again. So I kind of would say that this is my A starting point. And if I notice again, this is also the same thing. From the 2, it went straight before coming down. So I would say this is B. Then this is C. It's still the same, they're all starting at 2. Now, if you notice, from this point to this, from these 2 start points, I have 5. So I can say that 5 is the period. But let's take a look again. If 5 is the period, and I add 5 to 5, I should get 10, right? So do you notice that at 10, it's also starting again? So at every single 5 you add, you're going to be getting the same thing again. Now let us see. When it was at 2, it started coming down, right? From 2, it started coming down. So since the period is 5, if I should say 2 plus 5, because I'm adding multiples of the period, I should say 2 plus 5, I'm going to get 7. Now at 7, did it come down again? Yes, it came down again. So it's repeating itself. So the period is equal 5 milliseconds. And that's just it. So period is actually something easy to do. It's something easy to solve for non-sinusoidal waveforms. So this will be the end of this very clip. I'll see you in the next one.